Okay guys, today we are looking at inverse and joint variation. So in Algebra 1, you probably dealt with direct variation. And direct variation just looks like y equals kx. So where we're multiplying. Inverse variation looks like y equals k divided by x. So if you want to check for inverse variation, you would see if you multiply both sides by x, you would get x times y equals k. So when you're checking, if you multiply x times y and you get the same constant value for all of your x, y values, you have inverse variation. You want to check for direct variation, same process, divide both sides by x, we would get y over x equals k. So if you are able to divide y divided by x, you get the same k value every time. That would be direct variation. So direct or inverse, write a model describing the data. So you want to look at this data and see, am I dividing my x and y values, in this case w and h, or am I multiplying to get the same thing? So if I multiply x times y, 9 times 2 is 18, 4 times 4.5 is 18, 6 times 3 is 18, 8 times 2.25 is 18, 10 times 1.8 is 18. If I try to do y divided by x, 9 divided by 2 is 4.5, 4.5 divided by 4 is 1.125, and so on. It doesn't match, and so instantly we know, well, since this worked, we knew that anyway, that x times y, that means we are dealing with inverse variation. So then our formula would be y equals k over x, and our k value then is that 18, so it would be y equals 18 over x. That's the equation that you would write. X and y vary inversely with y equals 6 when x equals 1.5. What is k? Well, inverse variation is y equals k over x. So if I plug in 6 for y and I plug in 1.5 for x, multiply both sides by 1.5, so 6 times 1.5, k equals 9. So what is k? K is 9. That would be y equals 9 over x if it wanted the formula for inverse variation. Alright, volume of gas in a container varies inversely with the amount of pressure. A gas has a volume of 75 cubic inches and a pressure of 25 pounds per square inch. Write a model relating volume and pressure. So we use y equals k over x for inverse variation. But in this case, we want to relate volume and pressure. So volume equals the constant over the pressure. So we get 75 as our volume. We get k over 25 as our pressure. So to find k, we need to do 75 times 25. So I get k equals 1,875. So then if I'm writing a model, I have volume equals 1,875 over the pressure. There's our model that we would write. All right, joint variations. So one last piece here is a quantity that varies directly as a product of two or more other quantities. So it looks a lot like a direct variation, except we have more there. So K times X times Y would equal Z, and it could be A is equal to K times X times Y times Z. Joint variation varies directly as a product of two or more other quantities. So then if we write a model for these situations, it says Y varies directly with X and inversely with Z squared. So since Y comes first, we're going to write Y equals varies directly with X. So that means we need the constant times X and inversely with Z squared. That's how we write that model. If you want to pause and try the rest of these before you see the answers up here, now would be a good time to do that. For B, Y varies inversely with X cubed. So Y equals, inverse tells me it's going to be K divided by X cubed. C, Y varies directly with X squared and inversely with Z. So Y equals K times X squared over Z. Z varies jointly with X squared and Y. That's our new one. So Z equals K times X squared times Y. And then our last one here, Y varies inversely with X and with Z. So Y is equal to K divided by X times Z. The last piece says then you would find K by substituting for other variables in solving. So if it told you that what X, Y, and Z were, then you would plug those in and you would find K just like we did earlier. Alright guys, that's it for 5.1. If you have any questions, come in and see me. Otherwise, I'll see you in class.